Hello everybody, this is Carmen Killed the Cat, and welcome to the second part of the Lua 5.3 update videos, and also the last video in the Lua series as a whole. So, we only have three more functions to go over: string.pack, string.unpack, and string.packsize, but unfortunately there's a reason we didn't include them in the last video, and that's because they're very complicated, as you can see from this huge list. So, we'll go over string.pack first, and after that, I'll go over what this list means, and then we'll go over the rest of the functions. So string.pack. So string.pack takes a variable number of arguments. The first one is a format string that uses combinations of all of these to pack some number of arguments, so all the rest of the arguments you give it, some number of values, into a string for more efficient storage. So let's just give it some values. So 12, hello, -5, and I don't know, can we store a Boolean? It's probably just stored as an unsigned int. We won't bother with that. So we have three values to give it, and now we will give it a format string, and based on that format string, it'll pack all of these values together into a string that will take up less space than these would on their own. So now let's move on to what all of this means. So these first three options have to do with how binary data is read in the format string. It's called the Endian, and it's easier to learn how the Endian works with decimal numbers instead of binary. So say we have the number 1234 and in decimal. So if you went to any normal school system, you would think of this number as 1234. So we have a 1 in the thousands place. So that is the most significant digit in the number because it carries the most meaning. It means it's 1,000. That's adding 1,000 to the number. Then the next most significant digit is 2 hundreds. Then we have 3 tens and 4 ones. So this is how the number would be read if you were using a big endian, which we can see is an option right here. So let's write this. So this is how pretty much everyone learns how to read numbers. The most significant digit is first. And that is, in binary, it's called a big endian system, or the numbers have big endianness. That's the official computer science way to say it, although it sounds pretty weird. So you can also think of the number 1234 in a little endian system, and in this case, the number would be read like this. There would be 4 thousands, 3 hundreds, 2 tens, and 1 1 in a little endian system. So you can see we basically read the number backwards, and what this means is that the most significant digit, the thousands place in this case, is at the last position. So in binary, this would mean the most significant digit is stored at the smallest address, basically the last address, position 1 in the array. So usually binary is read with a big endian system, and if you don't want to worry about any of this, you can just use the equal sign option that sets the native endian. That basically just means let the computer choose for you. But if it is important to you, then you can define little or big endian. But if this is confusing for you, then just setting the native endian will work fine in most cases. So the next option is the maximum alignment. So you don't have to set this. It has a default native alignment, which is almost always 1. But basically what this option means is it's how many bytes of padding there is between each option you choose to encode in your format string. So by default it's 1, so there will be a maximum of 1 bit in between each option in your format string. But you can set it to be more, 2, 3, or any number really. But the default is 1, and usually it's best to stay with that. But if you want, or if you need to, you can change that, and the Square brackets with the n, I probably already said this, but this basically just means you have a number after it. You don't actually include the square brackets in the format string. So in the format string, if you were to choose the default, it would just be !1. If you wanted to change it to 2 bits, !2, !3 would be 3 bits. So wherever you see a square brackets and an n, that basically just means put a number after it. So those are all of the kind of control options. The rest are for encoding. So most of these are pretty simple. Lowercase b is a signed byte, so 8 bits plus, or not plus, 8 bits including the sign bit. So you have 7 bits of possible numbers, and then the first or last bit, depending on your Endian, is saying whether the number is positive or negative. Then uppercase B, or capital B, is an unsigned byte, so you have 8 full bits of space to store your number, but it can't be negative. H is a signed short, so just in most cases probably 4 bits of data, including the sign bit. Then capital H, unsigned short, so no sign bit, still you get 4 bits of data. L, signed long, 16 bits usually. Uppercase L, unsigned long. J is a Lua integer. The size of that is dependent on your operating system and computer. Uppercase J is a Lua unsigned, so an unsigned integer from Lua. T is a size T, which is basically just a define for an unsigned int, and it's chosen by the native size for your computer. Lowercase I is a signed int with n number of bytes. You put the number right after the I. Again, we see the square brackets here. And the default is the native sign for an int, or the native size for an int, sorry. Uppercase I is an unsigned int with n bytes. Again, the default size is native, so if you don't give it a number, it'll just choose a native size. F is a float with native size. D is a double, native size. N is a Lua number, so basically a double, and it's also probably native size. And Cn is a string with n number of bytes, so you define the number of bytes here. Z is a zero terminated string, which is just a string with a \0 at the end. S is a string with its length. You put the length in front of it, coded as an unsigned integer. X is just padding, and X, the capital X, just aligns based on the option you give it right here. So you put a number after it and it'll align based on that. And then if you put a space in the string, it's just ignored. So those are all of the format codes for string.pack. So now let's just create a few examples and see how they can be used. So let's go back to our example of string.pack here, and we can actually fill in the format string now. We can get rid of this comment just so it all fits nicely on one screen. So the first thing we have is an unsigned integer. So we have several options, but I'm just going to choose size t. We could basically choose anything that translates to a number, but we'll use capital T. And next we have a zero terminated string. All strings in Lua by default have a \0 at the end. You don't have to write it. So this does fit into the zero terminated string category, so the option is pretty clearly Z. So we put a Z here. And now we have an unsigned int, or not an unsigned int, a signed int, because it has a negative sign. So we have several options, but we can't choose anything that specifies unsigned. So we're going to use I. And we'll just use the native size for the int. We could say give it 2 bytes. I don't think it needs 2 bytes, but just to show you how the number system works. So now we have our string, and it's been encoded with our format string. So let's set a variable to it, and then we can also show what string.unpack does. So for some reason, if you try to print the format string, it just doesn't work. Oh, that's because, well, one reason is that I forgot a comma here for this whole video, and the other reason, I can increase the size of the console, it just doesn't print. The program never, well, the program ends, but nothing is printed out. I'm not sure why this is. I assumed it would just print a long binary string, but it doesn't print anything. But what we can do is we can use string.unpack. So we'll print it. So string.unpack does basically the opposite of string.pack. So we give it a format string, and we give it the same one we passed to string.pack. And then we give it the string that we're trying to unpack, so in this case x. And what string.unpack is going to do is it's going to use the format code here to kind of rip apart this string that we gave it and return them as the values we originally put in here, plus the last unread byte in the, or the first unread byte in the string. So if we run this, we get 10, hello, negative 12, and 13. So 10, we pass 10 in here. Hello, we passed in hello, and negative 12 is passed in here. And then the string.unpack found all of its values and stopped reading at bit 13. So that is string.pack and string.unpack. It's a pretty basic example, but kind of shows you the gist of it. So we'll do a few more examples with several more of the options. So we can just change some of the format codes around to show you what the rest of these options do. So if we were to change the size t to a unsigned byte, so we give it a capital B. So we'll be using less space because size t's are just the native size, and the unsigned byte is just 8-bit, so we should get a bit of a decrease in size here. So this last result, the number should go down. So it does. We get a 10 here, so it only had to read 10 bits instead of 16. So that's a way to save space. We could also use shorts. So capital H. Run that, and we get 11, so it's slightly longer. We could use longs. I believe these would be the same size as the size t's. Yep, we're back up to 13. And what else can we use? We can use the Lua unsigned, so capital J, and that brings us up to 17, so Lua numbers are quite big. We can make it a float, so now it's read as 10.0 because it's returned as a floating point number. We can make it a double. So that increases the size again because doubles take up a lot more space. Lua number, this will probably take up the most space, or at least as much as a double. Just my guess. Yep, it's read in the exact same way as a double. So Lua number and double are pretty much the same thing, although in some cases the size might change because double may have a differently defined native size. A fixed string with n number of bytes, so we can use that instead of z. So C, and it will have 1, 2, 3, 4, 5 bytes. So C5 for both of these. There's a bug on my computer. There we go, we still get hello. And what else can we use? We can use padding, so this won't actually change the results. Oh, bug just jumped at me. This won't actually change the results, but it will make the string slightly bigger. So we'll just put X's between all of these. X shouldn't be there. So X and X. And we run this and we get 18 instead of 16 for the number of bytes read. So that is the padding option. We can also show changing the native alignment. Alright, so to change the alignment, we just put an exclamation point and a number. So the default is 1, so we'll try giving it 2. And I don't know if I mentioned this before, but the alignment does have to be a power of 2, so 2 to the x, so 2, 4, 8, 16, and so on. So if we run this, we get 17. Notice it was 16 before. If we go back to the default alignment, it's 16. But past that, like if we were to go up to 4 bytes of alignment, the size doesn't change. So this is basically just putting padding between all of the options by default. It doesn't really change much, but the alignment does have to be a power of 2. So if we tried to give it 3, which isn't a power of 2, and we run it, we get bad argument 1 to pack format asks for alignment that isn't a power of 2. So it just has to be some power of 2, 2 to the anything. We can go 2048 if we want. It's a power of 2. And run that. And oh, I guess it has to be below 16. We can't have fun, unfortunately. So we can go up to 16, and the size doesn't change. It's basically just putting padding in it, but it is ignored when you unpack it. If you unpack it with string.unpack, but if you're reading it manually, the padding can be helpful. So we can also play around with the Endian a little. It shouldn't do much as long as we match the format we give to string.pack and the format we give to string.unpack. By the way, things like this can happen if you don't match them. So we set an alignment of 2 here and didn't do it in string.unpack. So we get negative 3072 as our last result instead of negative 12. So make sure you match string.pack and string.unpack. So we can play with the Endian. So, whoops. Let's set a little Endian, see if it changes anything. It shouldn't, as long as we match the format codes. Doesn't change anything, and we can go back to big Endian. Doesn't change anything, but if we don't match them, then things kind of go crazy. We get 4.58 times 10 to the negative 320. That's an extremely small number. Hello, and negative 2,817. So the strings stayed the same, but everything else is very messed up. So just a warning, make sure you keep the format string you give to pack and unpack the same, otherwise things will go wrong. So that's really, I think I gave an example for pretty much all of the options here. I guess the space, just to show, well, maybe not there, but in most cases spaces in the string are ignored. So if we run this, we get the exact same thing. Oh no. Oh, I see what I did. The function just gets rid of spaces in the string, so they don't matter at all. So now the last thing we have to go over is string.packsize. So let's just print it out. And basically what this function does is it gives you the size that the pack string will be with a format string. So pack size, all you do is give it a format string and it will tell you the size in bytes of the string that would result from that. And you aren't allowed to have certain arguments in it. You can't have, showed you right here, you can't move the mouse, you can't have variable length options like S, which is string preceded by a length, and you can't have Z, which is just a string of any size. So you can't use those, but other than that, pack size will give you the size of any format string. So let's just give it, trying to remember what we had. Let's undo it and I'll copy it. Sorry, I have very bad memory. Copy this. We don't need the Endian, it doesn't change the size. So print string.packsize, and we give it our format code as a string, and it tells us the size, or it gives us an error. Why is that? I have this on Lua 5.3, right? I do. 1 second, let me figure out what the problem is. Alright, so apparently ZeroBrain just doesn't like the string.packsize function. It keeps saying that it doesn't exist, so we're just going to do this the old-fashioned way with the Lua live demo. So this is just on the Lua website. You just go to the website, go to the download page, and it'll be a link there. You may have seen it when you were downloading Lua, but basically it just lets you run Lua 5.3 from the website. Before I knew that ZeroBrain could do Lua 5.3, I was planning on doing this entire video from this, so be glad that I found that out. So the string.packsize function just returns the size of the string that this code would produce. So you can see I already ran it. I'll run it again. We get 15, and that makes sense because the The string.unpack function as the last return returns 16, which is the first unread character, or first unread byte. So it makes sense that the size would be 15, and then the next unread byte would be byte 16. So that's the string.packsize function. It's a lot more simple than the other two. And that's all for this video, and actually all for this series. So this was the last video in the Lewis series, so now we're fully moving on to the Corona and C++ series, so hopefully I'll see you there.